All right, welcome to the next session in this series. In this session, we start with question number 39. In the previous session, we ended on question number 38. So here we'll be starting with question number 39. Cool. The question says the complement of a given set is a set of all elements in the. So we need to define what a complement of a given set is. And we know that the complement of a given set is what? Everything that is outside of that set but in the universal set. Okay, so elements that are in the universal set but that cannot be found in that particular set. So let's see which of these options is true. You say all elements in the set but not in the universal set. Okay, this is not true. It says all elements in the set and also in the universal set. No, this is not true. It says C says the universal set but not in all elements in the universal set but not in the given set. Okay, this is our answer. This is true because that is our complement. Complement means all elements in the universal set that are not in the given set. Okay, so our answer is what? C. Our answer is C. Cool. Let's go to question number 40. Question number 40 says the universal set U is this 1, 2, 3 up until 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's a universal set. It says if T is a set of even numbers and R is a multiple of 3, they are all subsets of this universal set, then find R union T complement. Okay, so first we need to write down all the sets. Let's write down all the sets, then we know what we are dealing with. Okay, so U is what? From 1 to 13. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's a universal set. And then T is what? Even numbers. But then these even numbers, they are a subset of U. So all the even numbers we're going to write should be a subset of U. Okay, so T needs to start from what? 2, 4, 6, 8, 10, 12. We add 14? No, we can't add 14 because 14 is not in the universal set. Okay, so we can't add 14. Cool. So that's when we end our set. Now let's go to R. R is a multiple of 3. So we start from 3, 6, 9, 12. Can we add 15? No, we can't add 15 because 15 is not in this universal set. Okay, we can add 15. We can't add 15. Cool. So we stop right here. So our question says we should find R union T, then we find the complement of that. Okay, so first we need to find R union T. That means all the elements in R and T together. Okay, so that will be 2, 3, 4, 6, 8, 9, 10, 12. So all of the elements together. You don't repeat them. If you find an element here and an element here, just write it once. Okay, cool. So R union T is the set 2, 3, 4, 6, 8, 9, 10, 12. Okay, cool. Now we need to find out the complement of this. Okay, so R union T sorry for writing the union like that. Let me write it properly. We have R union T complement to be all the elements in the universal set but cannot be found in this set. Okay, so let's compare this set and then this set, and then the ones that we cannot, that are here but are not here, that will be our answer. Okay, so let's open the set first. Okay, so we have 2 here, so we have 1 here, 1 not here, so that will be part of our answer, right? So we have 1 We have 2 here, 2 here, so 2 will not go. 3 here, 3 here, 3 will not go. 4 here, 4 here, so we can't write it. 5 here, 5 not here, so 5 comes here. Okay, so let's write 5. 5. Okay, 6 here, 6 here, so we can't write it. 7 here, 7 not here, so write 7. 7. Okay, let's move on. We have 8 here, 8 here, so 8 cannot come. We have 9 here, 9 here, 9 cannot come. 10 here, 10 here, 10 cannot come here. So we have 11 here, 11 not here, so 11 comes. Okay, we have 11. Okay, and then let's move on. We have 12 here, 12 here, so 12 will not go. We have 13 here, 13 not here, so 13 will go here. 13. So this is our answer. This is our answer. So let's see if we have it right here. 1, 5, 7, 11, 13. Yes, right. You have it right here. So our answer is what? Our answer is A. Cool. Let's move on to question number 41. It says there are 36 students in a class. Each student offers at least one geography or commerce. If 30 students offer geography and 26 offer commerce, how many students offer commerce only? Okay, so our universal set is 36 students. Okay, so let's write that down. Let's write that down. Okay, that's our universal set. Our universal set is what? 36. Okay, so now let's draw two circles to represent geography and okay, geography and commerce. Let's draw another circle here. Okay, so geography is equal to what? How many students offer geography? It says 30 students offer geography, so we have 30 right here. We have 30. Okay, and then how many students offer commerce to be 26. Okay, 26. Now our question says at least, it said each student offers at least one of geography or commerce. What that means is that no one is outside of these circles. Everyone is inside these two circles, right? Because in some situations you might have students that are in a class but they don't offer geography or commerce, so they will be inside the box but not in any of these circles. Okay, but in this case we've been told that each student offers at least geography or commerce. That means they will be found in either of these two circles. Okay, now our question says how many students offer commerce only. So commerce only is we want to find a student that offer only commerce. That means students that are in this region. Okay, let's circle, let's shade that so we know what we are talking about. So students in this region. Okay, that's what you're trying to find right now. So what that means is we need to find the amount of students, the number of students in this region. Okay, but here, okay, let's call that region X. Sorry, let's call that region X. Okay, X. Cool. Now if we take this circle, this whole circle, the geography circle, and then we add X to it, we should get what? The universal set. Okay, because this area plus this area plus this area should give us what? The universal set. But we know that this whole area is what? Geography. So we've already taken this side and this side together. That will be geography. So what is remaining is what? This side, which is the X. So if you add 30 and X, we should get 36. Okay, so we have 30 plus X should give us the universal set, which is what? 36. Okay, so X will give us what? 6. X will give us 6. So our answer is what? 6. 6 is our answer. 6 is our answer. Good. Let's move on to question number 42. It says if P is equal to this set, if P is equal to this set and Q is equal to this set and R is equal to this set, find the number of P intersection Q intersection R. So P intersection Q intersection R means the elements that are common to P, Q and R. Okay, so let's look at which elements are common. are common. We have 2 here, we don't have 2 here, so that is not common. We have 4 here, we don't have 4 here, so that's not common. We have 6 here, we have 6 here, we don't have 6 here, so this cannot enter into the set. Okay, we have 8 here, we don't have 8 here, so 8 cannot work. Okay, let's move on to 10. We have 10 here, we don't have 10 here, and we have 10 here. Okay, so what that means is that we don't have any single element that is common to B, Q, and R. Okay, even 10 is here, 10 is here, but 10 is not here. So no element is common to each of these sets. So that means the number of elements in this set will be what? 0. So answer is what? 0. Or answer is 0. Cool. Let's move on to question number 43. Question number 43. Cool. Question says, if P is the integer x such that negative 8 is less than x less than negative 7, then find P. So P is what? So now this set simply means that the element between negative 8 and negative 7, which is an integer. Now tell me which element is an integer, which value is an integer, and is between negative 8 and negative 7. Think about it. Absolutely no element, right? So no element in this set. So that means our P will be an empty set. An empty set, which is A. Okay? An empty set, which is A. Alright. So in the next session, we'll be starting with question number 40. This is question number 45. Okay, so I'll look for that, and then we can go to question number 44. Sorry. Thank you so much for joining this session, and then see you again in the next session. Bye.